Welcome to homework.
In this problem, we have two particles in a diagram, and we wish to calculate their angular momentum about point P. So the first thing we will do is take the anti-clockwise direction as positive and find the angular momentum of particle A, H, about P. So this is made up of the x and y components of the momentum, the angular momentum of particle A. So remember, the angular momentum is the distance of the particle to the point multiplied by the linear momentum. So that's 2.5 working with x components into the linear momentum for particle A is 3 times 8 times cosine theta, which is 4 over 5. Now the y components, there's a separation of 7 meters and a linear momentum, which is its mass 3 times its velocity v, which is 8 sine theta, which is 3 over 5. And so we get the magnitude of the linear momentum of particle A about point P to be minus 52.8 kg meter squared per second. And so the vector angular momentum of A about point P is minus 52.8 in the k direction, kg meter squared per second. Now we'll do the same for particle B. We again will take the anti-clockwise direction as positive, and we'll label the magnitude of the angular momentum of B about P as h. And so this again is the distance in the x direction, or the distance separating the x coordinates of B and P, which is 4 meters, into the linear momentum, the x component of the linear momentum, which is 4 times 6 sine 30 degrees this is the y component in this case, minus the x component, which is 8 into 4 times 6 times the cosine of 30 degrees. And so we get the magnitude of the angular momentum of B around P to be minus 118.28 kg meter squared per second. And since that's the magnitude, we know that the particle is moving about the z-axis. So the vector angular momentum of B about point P is equal to minus 118.28 in the k direction, and that's kg meter squared per second.